Okay, hello everyone. Okay, in this video, I'm going to show first moment of area calculation. Okay, so and the first moment of area calculation is very important in the shear stress calculate shear stress in the beam. And we use 12.3. Okay, we previously demonstrated this problem before. Okay. And I want to add one extra problem. Say, okay, if we want to calculate the shear stress at this point, for example, if my point of interest right now is here. Okay, here is called D. Okay, and D here is the 0.05 meter. Okay, that means a 50 millimeter. Okay, so and what is QD? Okay, what is QD? Okay, so I just want to do more demonstration on the first moment of area calculation. Okay, so right now our D is below the neutral axis, right? Below neutral axis. Okay. And so, okay, if our point of interest is below neutral axis, in previous video I say if your point of interest is below the neutral axis, so calculate the first moment area below the point. Okay. So so right now this D is really under the neutral axis. So we calculate the first moment area below D. Okay. So below D, what we have? Okay, below D we will have the T shape. Okay, this T shape. Okay, but again, I think it's a reverse T shape. Okay, there's a point of interest over here is D is here. Okay, and above is the neutral axis. Is neutral axis is here. Okay, don't forget neutral axis is here. Neutral axis. Okay. Okay, so and then we calculate the area below the neutral first moment area below neutral axis, and below the neutral below sorry below the point of interest. Okay, calculate Q below the point of interest, and below the point of interest right now we have reverse or upside down T shape. Okay, so and the T shape is a complicated shape. Okay, and then we will have to divide the complicated shape into a simpler shape. Okay, here is one rectangular. Okay, and here is the other rectangular. Okay, okay. So I think we just call this one, and call this is two. Okay, so the QD. Okay, maybe I use another color. QD. What is QD? Okay, okay. Right now we have two area, right? One and two. So it's A1 Y1 plus A2 Y2. Okay. And here we need to summarize some geometry information. Okay, so here is 300 millimeter. Okay, here is 300 millimeter. It's based on the information on this problem. And here is, I think, it's 20 millimeter. Okay, here's 20 millimeter. Okay, so and okay, what is a D? Okay, we say D here. I intentionally say I say D is here is 50 millimeter. Okay, here is 50 millimeter. Here is a 50 millimeter. Okay, and the thickness here. Okay, this here is 15 millimeter. 15 millimeter. Okay. Okay, so what's our A1 right now? Our A1 is 50 millimeter times the 50 millimeter. Okay, and what else? Y1. Okay, Y1 is the centroid between the centroid to the neutral axis. Okay, for area one, the centroid is here. The centroid is here. Okay, so here is your y1. Okay, the distance between the centroid to the neutral axis. Okay, don't forget it. Okay, so and what's the distance here? Okay, let me see. First of all, let me check my equation. Okay, yeah, it's correct. Okay, so what is our y1? Okay, what is our y1? Y1. Y1. Okay, so here is 50. The neutral axis, I think here is, so I think, okay, neutral axis, I think so. Okay, because this is symmetric, so I think here is 100. Here is 100. Okay, okay, so here is 100. Here is 100. So here is 50. And this is the centroid of this the pink area, so it's 50 plus 50 divided by 2. Okay, understand? 50 plus 50 divided by 2 and times with 10 to the power minus 3. Okay, is equal to 75 times with 10 to the power minus 3, and it's meter. Okay, so that's the white one. Okay, and what's our A2? A2 is the blue area. Blue area is equal to 300 times with 10 to the power minus 3, and 20 times with 10 to the power minus 3. That's for A2. And what's the Y2? Okay, the distance between the centroid to a neutral. Okay, that's the centroid for area 2 is here. Okay, so this is your Y2. Okay, it's hard to recognize. Okay, Y2 is here. Okay, so here is 100, and this is the centroid of area 2. So here is 10. So it's 100 plus, we call 100 plus 20 divided by 2 and times 10 to the power minus 3. Okay, so what's our QD? Okay, you have A1, Y1, and A2, Y2. Okay, so I think that you will have A1, Y1 is 5.625 times to 10 to the power minus 5 and plus 60.6 times 10 to the power minus 4. So overall, your QD is 7.1625 times to 10 to the power minus 4. So if we want to calculate the shear stress at this D point, okay, we have QD is here, okay, and so the shear stress at D will have the VQD over IT, okay, and you put everything in there. For this problem, is give us the shear stress is 80 kilonewton. Okay, and the QD is 7.1625 times 10 to the power minus 4. And I, we already calculated the I before, so I don't want to calculate it again. It's 15.56 times 10 to the power minus 5. And our T is here. T is here. T is how many? Okay, it's 15 millimeter. Okay, it's 15 millimeter. So after all, what's your value? We will get a 24.55 megapascal. Okay. Okay, so let's this short video just demonstrate the first moment of area calculation. So let's you get more familiar with the first moment area calculation. Okay, because yeah, you need to get used to this. Please get used to this. Okay. Yeah, it's not a really straightforward one. So okay, so I mentioned AI, YI, you need to careful, you need to know what's area you are talking about and what's the distance between the centroid to your neutral axis. Okay, central area to a neutral axis. Then you need to find the Y by yourself. Okay, no one will tell you. Okay, so I just okay. So the short video I finished demonstration here. Okay, so I'll see you in another video. Bye bye. Bye. Mhm.